Okay.
Yeah, go ahead.
Can you see my screen?
I can see your screen.
I
The
think so.
audio could be better. If you can switch your Zoom audio, don't use AirPods for microphones. AirPods are very bad microphones.
Okay.
Even though it looks like I'm using my AirPods in my ear, I actually always switch the Zoom to laptop microphone. It's much better.
I'll change that.
Should be in like the Zoom clicker thing. No, I don't even like AirPods Max. I've tried it. It's not great.
Is it any better now?
Yeah, much better.
Oh, sweet.
Okay, yeah. Just introduce yourself because you're a new presenter. I'd love to get to know about you and why you're interested in GR.
I was working as a backend engineer. My name is Venki, by the way. Nice to meet you all. I took a sabbatical to do to understand like the current ecosystem and to experiment more with the AI tools and also understand the fundamentals a lot. So I took a break. Uh, and then I'm trying to read papers, but so far it's not working out for me, the self-study. But I'm still like trying to make sure like I get something positive out of this sabbatical. This is my first time presenting the paper. I'm not sure like how it goes, but I feel like I put a lot of attention to understand the details because I'm presenting it. Otherwise, I would usually skim through
Yeah,
them.
yeah,
Yeah. So it's a good like decision for me to volunteer for this.
agreed. Okay, if you want, you can make your paper full screen and then we can get into it.
Okay.
Yeah.
So should I give an overview first?
Yeah.
So this is it looks like a mixture of expert transformer on the base model, and then what they have done differently is like they want to make sure like this model has a ARC capabilities, agentic coding and reasoning abilities. So what they have done, they post training they've used like two different ways to train this model. Like stage one they trained an expert model for each specific task, like agentic reasoning and coding. And then once they have like expert model, they distill these capabilities into one model. So that's why this model seems to have like all three capabilities, and this model is able to like have like a switch between modes, like long thinking modes and then quick response modes. I haven't actually used the model much, but I asked Claude to generate some task and prompt to verify these capabilities. So maybe post this talk, we can go through if this model is actually looking good with those tasks. But basically, this is a mixture of experts, and yeah, and these are like some metrics they provided with ARC capabilities. I'll move to the second.
Yeah, I feel like ARC is a little bit co-opted by ArcAGI, but ARC has a definite definition, which I think you're showing on screen right now.
Right. Oh yeah, the ARC challenge. True. So these people like they say ARC to define like if the model has agentic or reasoning or coding capabilities all together in one model instead of using multiple models to achieve different performances. So they clearly define the ambition here. So how often like yeah, this seems like the main drive behind this model training to have all these capabilities in a single model. And then the paper mostly quickly goes through like what they have done, and then also the RL training pipeline and how they approach like a data synthesis for training, etc. But these are like a bunch of metrics they've mentioned here, and they have now a smaller model as well. But they haven't mentioned much about the smaller model. Apart from, I'm assuming it's a distillation. Yeah, these are like bunch of
Yeah.
metrics, how it performed on a various metrics. I tried to see if they have like the training loop made available. I don't think they made the training loop available for open source. I think the only weights are available in the Git repo. So yeah, architecture, the fundamental architecture is like a mixture of experts. I feel like the only thing they changed is they used a Muon optimizer instead of Adam. I'm not sure if Adam is like standard, but they're using Muon. They mentioned this down somewhere here. Yeah. So they used a Muon optimizer, and then what else they've changed?
Yeah,
Yeah, they
so for context, basically for the past few years, the Atom and Atom W optimizers, they've been very much the standard defaults. There hasn't been much progress. Like Atom came, then Atom W. The recent Kimi K2 paper, it's like the big model that came out after DeepSeek. They switched to a Muon clip optimizer. It's like better training stability. They have a very pretty loss curve. So that's kind of the background of the optimizer.
um, And one thing they have done, they have this is like the general pattern they use. Like they started with 4K context window, and then they increased the context window to 32, and afterwards like 128, and they mentioned like how they collected the data. So basically, yeah, they use like web crawling to have like English and Chinese web pages, and then they use like a quality metric. Um, so here they mentioned like they divide the crawl web pages into buckets with different quality scores, and then they're upsampling the documents so that like the initial like the base data is much higher quality, and then they were using like this semdudu to basically deduplicate like uh, data. I mean the duplicate data. This basically mentions like what they have done with the pre-training data. And one thing they said like they used like grouped query attention with partial rope in the attention block, and then also they mentioned like attention heads or more. So one of the claim was like having more attentions and wider instead of like instead of having deeper over the wide, like it increases the reasoning capabilities. And
And Venki, before you go forward, you said something at the beginning of this discussion. So did I just wanted to make sure that I got this right. So did they train three separate models, one each for agentic reasoning and coding, and then they distilled all those three models into one model? Is that how they approached this?
so for the base model, they use like the same pre-training for the base model. Once they have the pre-trained base model, in the post-training, they used like they created like three different models.
And then did they then distill into one other model?
Yeah.
Okay.
Yeah. So in stage one, they used expert training, and then stage two, they unified.
Ah, okay. Thanks.
On the previous note here about attention heads and wide versus deep, I think it's been interesting with the other few late papers. So like once again, the Kimi paper talks about how they do less attention heads because a very long context, it's like half the memory bandwidth that's required. And then OpenAI's open source model, they talk about how they go for a wider MOE as opposed to a deeper one. And that helped with like training stability and stuff as well. So it's like interesting, these little notes that, you know, normally you just take at face value. You're starting to see some of the differences with different models and why they pick what.
So, um, so in pre-training, they have like a multiple stages, and like they use different data and then also different context sizes. One thing they have done with the code, like they use like a mostly GitHub for code, and one thing I observed, like they used they combined like files from same repo to get a better understanding of relation between different files in the code base. I thought that's interesting to have that semantic meaning embedded. And then also most of the times, like once they crawl the data, they were using some kind of model to predict the quality of a particular page. And then based on the quality, that seems like they upsampled the particular high quality data. That seems like a common pattern they used for all the data. Yeah, so they mention upsampling a lot based on the quality of the content. So the pre-training, I believe, like they're trying to have like a base model that, I mean, with high quality data, and then second phase, like in the mid-training, they were using a repo level code training. It's basically they increased the context and they added like uh, more data, like a long context and agent training. And here I feel like they use a lot of synthetic data generations and synthetic data, especially for agentic tasks and for reasoning tasks. One thing, so they included these as well to improve the coding abilities. Um, yeah, and they mentioned like they used a deflect formatting. Uh, I think it helps like to generate better, or to understand or to review better, having this deflect format. And here they mentioned like they boosted like context length from 32K to 180K, and they upsample only long documents. I mean, that makes sense. Yeah, it's the same thing. 4K to 32K and then 128K. I'm not sure I understand. Oh yeah, so if during pre-training, they didn't use like a, so I think this basically best fit packing, it basically truncates the context to given length. So in one of the stages, they didn't use that, so that like it becomes like a good data augmentation strategy. And then for mid-training, they applied best fit packaging, so that like I think they compress the context into a given context window, so that like it has it's like a summary generation. I think it's like summary generation. Frankie, you have a question?
Yeah. Could you explain a little bit what they mean by upsample?
Uh, I think they yeah, I'm assuming it's like downsampling, upsampling, right? Like they want to have like a, if you have like multiple buckets, you want to get like more data from a particular bucket rather than less data from other buckets. Suppose if you have like equal distribution, you probably get like if you do 1,000 samples, like the distribution would be even, right? With upsampling, I believe like you have more weight to certain buckets to get the high quality data. Vibhu, do you want to add anything?
Typically, that's what upsampling is. It's not just more weight to different buckets. Sometimes I'll just do multiple epochs, right? So for some long context or for some like high quality, it's not uncommon that they do multiple passes of the same data. And downsampling as well, you know, like if you have a lot of generic text, it's like filtering is a form of downsampling. But yeah, sometimes it's just in more epoch.
Thanks. And then I know you just touched on that best fit packing. What does that actually do?
Uh, Based on my understanding, I think they're trying to summarize so that it fits actually to the context. I haven't actually verified that. I assumed it.
Oh, sorry.
And
What's a basic procedure? I don't quite understand. What are they doing?
um, I I haven't actually verified what exactly they've been doing. Like I haven't seen the algorithm. I just assumed that like they probably like summarizing the context to fit better. Suppose like if you have like 128K or like a lot of data, it's better to have like a summary so that like you have like main points in the limited context so that like uh, the queries can, I mean, the LLMs can focus better on the what's going on rather than like whole context.
Okay, got it. And then
If anyone has a better explanation, please chip in.
sorry, I have a separate question, Vicky. What is their rationale? So I think they're saying pre-training, you begin with something smaller, and then mid-training, you introduce longer. Is this kind of like, you know, like going? I forgot what they call it, curriculum training. Is that kind of like the thought process here, or why? What's the reason for doing it this way?
Uh, the curricular training, I think they used it in the context of oral, right? Like to get like better reward models. But I think this here it's simply extending the context so they can. I mean, we can put like a lot of data into the context. There's just like I feel like 4K, they have like a good base, like the weights are set in a better way here. And then once we increase the context, I believe like it can generalize well, and then it can have like the attention uh, can be spread without losing the actual value. Or that's what I think here they're doing.
Does it have any data showing like, I don't know, ablations showing that if you do it mixed together, it's like this, or if you separate it like this, it does something differently?
Oh,
I
I can chime in here actually. There's two parts of this mid training, right? One is context length extension, which is typically not what you consider mid training. Context length extension can just happen at the very end of all your RL, all your post training, right? You can just do more training on long context, and that kind of works. Now, what this is the reason it's more mid training is because you're going from regular pre training, just next token prediction, to some form of specialized data, right? So repo level code. This is long context, full code base, synthetic reasoning data, long context agentic data, right? Now, the fact of the matter is it's not like exclusive that they're just doing this, but they're also doing long context. But it's pretty common, right? You don't see like reasoning data at short context, right? Because oftentimes the queries that go into these, like the system prompts themselves, are already pretty long. So same thing with the reasoning traces, right? We just don't do reasoning at short context because you need context length for actually doing reasoning, right? You're not going to do reasoning at 4K context. So it's mid training more so because of the type of training they're doing, not because of context. But yeah, they didn't just do it as a separate step, which is like okay too. Like long context is not super like unknown, right? All you do is just train on long context for like a couple 100,000 or a couple million samples, and you're kind of chilling. And with that, like, you can just mix it in wherever. But in this case, it's mid training because the type of data. And then that's like the first question. On the other one about best fit packing. So one thing you can do if you have like long context, let's say you're training on like 32K context, right? And you have a bunch of sequences that are like short, like 4,000 sequence length. What you do in terms of packing is you can concatenate multiple samples into one sample, right? So like if I have 8 queries that are 4,000 sequence length, I can batch them all together and make one sequence of 32K. And that's best fit packing. That's more efficient on GPUs. Or you could not do that and you could just train normally, right? So you could do best fit packing by packing multiple short sequences into one sequence, or you could not do it. And then they talk about what they do here, but that's what best fit packing is. It's where you pack short sequences into long sequences, and then there's pros and cons of both. I think for them, they say in pre-training they don't do it, so it's not as efficient on the GPUs. They just do random truncation, right? So sometimes different sequences and batches will be different lengths, and that's okay. It is what it is, and they talk about why they do this. And then in mid-training, they do it because context matters, right? You don't want half of a reasoning trace to be cut off because you're out of sequence length, right? You want stuff to be the same length. So in mid-training and reasoning, they do it. Like, you don't want to chop off a code base just to be efficient in GPU. In pre-training, they're like, it's good, it's data augmentation. Even if you don't have half of the stuff, it's fine. It's more efficient on our majority train run. But sorry, that's like two topics in one. I hope
Thank you.
that made sense.
Thanks, Ibu. So, but when they
That
kind
makes
of
sense.
concatenate this, like say 8K into 32K, does you're not like masking anything, right, on the attention? That is, the stuff that you concatenate can still
Yeah.
attach to the previous stuff, right?
Yeah. It's weird like that. There's different techniques to do packing, but like there are techniques of add-in tokens to forget stuff before. But I mean, that's like, I don't think they're doing any of this. The real point of packing is just you keep sequence lengths similar, and it doesn't have like contamination in training data, right? So with reasoning, I don't want in the same training batch code about one library with something completely irrelevant to think about. But it's just beneficial if you keep it training. But then if it's like just regular like storybooks, right? Let's say you have like a Harry Potter book and then half of it is added in with a Lord of the Ring book and you're just predicting next tokens, it's fine, like it's just common. But I think that's high level what this stuff is. Someone else should do a little bit more research into it. I just know that it's typically done in pre-training where the type of data is not as important, and you don't want to do it in reasoning.
Okay, thank you.
And there are
Makes
approaches to how you can better pack stuff. And there's like some paper that talks about like adding special tokens, like how encoder decoders used to have like CLS tokens. I have more paper on that, but I haven't looked at it.
Thank you, Vibhu. And also, I don't think they mentioned a lot of ablation studies or why they have done on the pre-training stage. Most of their focus on like making sure the RL works, RL is effective, and then they're able to improve the capabilities. So this paper, like a lot of the times, the charts or the graphs are basically talking about RL pipeline, not the pre-training. Yeah. So they mention about like hyperparameters. Like I already mentioned, like they used a Muon optimizer. I couldn't understand like some of these things, but prima facie, I feel like uh, yeah, I to be honest, like I haven't understood like this completely. So this one's like a warm, stable decay schedule. Like they're changing the learning rate on. They mentioned like how they change it, why. And then they also used like a batch size warm-up strategy. So batch size was increased gradually from 16 million to 64 million training. And they used like Muon optimizer because it feels like accelerate convergence and like it can tolerate large batch sizes. Yeah. If anyone have a better understanding, please help me out.
Yeah, I don't know where to get these numbers from either, but usually it's just you know, it's one paragraph, but they spent like 3 months updating different parameters.
Yeah. I'll move on to the post-training. I feel like this is where the majority of the work. I think it's very carefully crafted and created. As I mentioned earlier, like they use like a two-stage approach. Like in stage one, they created expert models for each specific task, and then stage two, they use distillation techniques to integrate these multiple experts. And then they mentioned like in supervised fine tuning. So they do this SFT for both stage one and stage two, and in expert training, like this is basically like making sure that the model has basic capabilities to either to generate or to respond properly. Other than that, it doesn't have like any specific like a tool for agentic or reasoning or capabilities. Yeah, in SFT for stage two, it's like they're distilling capabilities from different expert models, and then making sure that like it gets the capabilities from three different experts. Yeah, like same thing. So here they mentioned like how they perform these tasks. Um, One thing they have done differently for code. So I feel like in regular models, it seems like they have to like for text data, they have to use like a lot of escape characters. So this is far. They say that like that's fine for like a model specifically designed for coding tasks, but they want to have like a general capability for this model, right? So instead of using a lot of escape characters, they decided to format the data into this XML format so that they don't have to use like escape characters. That's the one thing they have done differently. So in I couldn't hear you. I'm sorry.
You're really soft, RJ. I don't know what happened to your audio. Nope. You know, what happened, RJ? You could type, I guess. I'll be RJ's voice, but also he's a veteran. I don't know what's screwed up there. RJ says, is this a new token or just a tag? I'm not sure there's a difference.
Yeah, I'm not sure. I think it's maybe they added these like end of text tokens as part of vocabulary so that like we don't parse them, but I'm not really sure. Is it the right? I'm not sure I understand the question itself. Let me see the. Yeah, I think it's a new token. Yeah, new token in the vocabulary, but they haven't mentioned it.
All right, fair enough. Usually for this kind of stuff, they do add new tokens. DeepSeek v3.1, which dropped yesterday. You can see an example of how they add tokens for this kind of stuff. I would imagine GLM to be the same.
Does anyone know what does GLM stand for?
No idea. You could probably look it up.
So I think here they also mentioned like by distilling from output of distinct experts, the model learns quickly, applying long context of like COT reasoning for each task, and then it can switch from thinking long or also thinking short without any explicit suggestion. And third one, the rejection sampling, I feel like, so while sampling, they want to make sure that like they sample high quality data. This rejection sampling, they basically mentioned how they have done that. They want to make sure that it's in the valid format, and then verification with an objective. Like I think the math or science, you can have like objective answers, even the code. So they did that part as well, and then they have like a reward models for subjective questions. It can be either oral HF or oral AI, and then they use this metric to distill the sample. Reject the sample, and then I feel like the tool calling scenario is very interesting. They go deeper in later stages as well, how they orchestrated like the tool calling oral. Yeah, I'm gonna talk about that later section. And then also seems like they selected few prompts to improve the or like they deleted like some of the prompts which are not conducive to better results. They mentioned that here, and they state that like it improved the reasoning capabilities. So here they mentioned like how they constructed the agentic SFT data. So I feel like they use like existing frameworks like MCP servers to get like a basic features, and then they created they did task synthesis. It seems like they use like whatever the documentation they have for MCP servers to create tasks. That seems like a very yeah, it's interesting approach. So they used LLMs to comprehend functionalities and then generate relevant queries and tasks. And for fragmented, like they did follow similar approach, but they first they select like a representative subset, and then they construct the task based on that. Yeah, single step and multi-step tool calling. I believe this basically says that like in the reasoning process, you may have to use uh, like one call or multiple call at different stages. And then hybrid.
Hey, Venki, sorry, just a quick kind of, maybe it might be a stupid question, but I just wanted to confirm. Is it the actual, like, them training specialized experts? Is this different to the other models? Do you know? Like, is this one of the different parts of this model?
I mean, I know a lot of times we other LLMs do distillation, but I'm not sure. I haven't read any paper. Maybe Kimi or other papers does it. I don't know.
Yeah, I was curious too about whether. Can you guys hear me now, by the way?
Yes.
Yeah, I had my headset microphone on. Sorry about that. I was also curious about what was the motivation for using distinct experts versus just using good rollouts. And I kind of, the conclusion I came to for myself was that they have this like multi-stage curriculum where they mention a couple places where they keep sort of doing like rollouts of their own data, and so that maybe in the early phases it's easier to generate distinct experts than it is to generate one model that's good at all three. And that's why, so that like in the process of generating a generic model, it's easier to do like basically fine-tuned models that are good at one thing and then distill them all into the same model. That was my take. I'm not sure I've ever seen this before myself.
I agree. In the oral setup, like they mentioned this, they needed like different architecture for different type of reasoning tasks or reinforcement learning tasks. So maybe that's why they.
So they actually changed the architecture for each expert.
I think so.
Interesting.
Yeah, they have a slim RL, and then they mentioned sometimes like for software engineering task, like they had to have like Docker containers and other stuff. Like so they mentioned that like a bit later in the page, but I'm not sure. Like this
So
is the
like the training architecture, not the model architecture.
right.
Oh, I see. Okay. Yeah, no, but that makes sense why you would also want to split that. Okay, that's actually really interesting.
Um, Right. So here they use like LLMs. They used existing frameworks, and then they did task synthesis based on these frameworks, and then so I feel like a lot of times they do this synthesis to get the data required for training, and then also they use like quality filtering to make sure that they have like a high quality data goes into the training. Yeah, and then they use LLMs to generate this multi-step tool called into trajectories. Uh, yeah, we'll move on to reasoning RL. One thing I think they use like a GRPO. I feel like this is like a common framework. Even DeepSeek uses this. I'm not sure. I'm not exactly sure what is this loss term. Yeah. So one thing I understand based on this, like, so yeah, if I understand like RL correctly, like for each task, like you get a reward, and based on the reward, you change the policy. You take an action based on the existing policy, you get a reward, and then change it. So here they want to have like a if the task is like too complicated, like the reward would be always 0. So we don't have any gradient to train the model better way. So they want to make sure that like at particular stage we get like appropriate reward, or like we get a reward so that like we can train more or train better. So so in stage 1 they use like a moderate examples, moderate difficult data, and then after like certain point, like after the certain training steps, they use like extremely difficult data so that like they have a better gradient, or the model is well trained enough to produce a gradient or produce a reward. um, I think that's what I understand from this curriculum-based learning. Yeah, and they try to use like a different context, like 16K, 32K, 48, and 64. I believe at the end they decided like it's better to use like a 64K context window. There is no additional advantage with the starting with the small context window and then increasing the context window to 64K. Rather, they can do 64K training from the beginning. Yeah. Yeah, they also mentioned like this two-stage approach, increasing the difficulty produces better performances, better performance. Yeah, also they mentioned like a single stage RL at 64 output length. This is the for that in second paragraph, like this chart. They mentioned like they used a different loss function, and this basically this chart like using different loss function for like coding tasks. I think that comes in this paragraph, but we can talk about this first and then. So temperature, I believe it's like a common temperature we see in LLMs. Like if the temperature is high, it becomes like a more exploratory. If temperature is too low, it becomes like a very deterministic, right? So instead of using a standard temperature, they try to use like a dynamic temperature. And then they have like a certain validation to make sure that like the temperature they have chosen is working fine. Yeah, so here they mentioned how they how they have chosen temperature based on the validation set. And they mentioned here like why they have taken that approach. Yeah. So here they mentioned like for code RL, the loss calculation is critical for training efficiency. And then instead of using, or they used like a token weighted mean loss rather than conventional sequence mean loss. I haven't exactly know what's going on here, but I'm taking by the word. And also this chart seems to be a case like token weighted average, token weighted mean is working better for oral training compared to the sequence mean. And they also mentioned like what they have done. I feel like so for science RL, I feel like a lot of the times like they have like a verified answers, so it becomes easier for training to get like exactly to get the reward if it's accurate or not, the reasoning steps. For agentic RL, so I feel like here they use like both humans and AI to get the feedback. I'm not sure what. So this basically like they generated multiple samples, and then they're trying to like this is just like a training loop. Uh, will you be able to comment on this?
Yeah, I mean, this is it. Am I reading this right? Someone else should comment here, maybe. This is GRPO without the KL divergence, right? This is just a reiteration of that statement from above, or not?
Yeah, right.
They don't seem to. Did they mention why they removed the KL divergence from the loss term?
I'm not sure. I don't think I come across that reasoning.
Yeah, that seems a little bit magic.
Yeah, I'm not even sure. Not super confident. Like I understand this part. This lot of like oral heavy.
Wait,
Sometimes I
so
understand.
there's two things to dropping KL divergence penalty stuff. In other work, they also, I don't remember which paper it was, but in one of these they significantly dropped the penalty for KL divergence, and then they like decayed it so it didn't have an effect later on. So KL divergence is to keep the model from going too off track, right? But lowering the penalty allows the model to explore like the random space a bit more. So the paper basically really dropped the penalty for KL divergence because it allowed the model to explore a broader set of generated tokens, right? It's like similar to temperature. It allows it to explore more freely. And in return, going down different paths, it eventually converges to an answer. In this case, they're dropping KL divergence because they're doing this on math and code, right? So stuff that is objectively verifiable, as long as you can verify that that answer is correct, you're fine, right? Like you're able to get reward as long as you're able to start solving the questions. So in more broad terms, like RLHF with like, preference feedback and DPO and stuff, it's still a concern, right? Because you can get slight reward for preference-based outcomes, but in stuff like math and code, as long as you end up at that verifiable answer, you're kind of chilling, right? You don't really need a KL anchor to supervise the policy reward. Like it's okay. And then there was another paper we covered recently that like echoed this.
Yeah,
Uh
thank you,
yeah.
Vivu. That's really clear. I think it was the Kimi paper, right? That they did this in, maybe.
Sounds about right.
All
I
right.
wish I
Anyway,
knew.
yeah, that's really good insight. I appreciate that.
This is also just like me spewing my bullshit of what I think about it, could be wrong, but seems legit to me.
I recall that too, so that sounds right to me. Good enough for me.
In this paragraph, like they mentioned that how they calculated reward for the given specific task. So for web search task, like they use like a final answer as a reward, and then for coding agents, they use like verifiable test cases for rewards, and then yeah, and for tool calling, they try to see the format of the particular trajectory, and then they basically like either proceed further or like receive a zero reward. Um, and then basically the cold in stuff like cold start SFT cold start model, like it has like a basic understanding what's going on, how to deploy back, but and then they did like like once training has reached like certain steps, like they started applying self-distillation, like by replacing like the data generated by the cold start SFT to the RL train model. I think this is the like expert model. Yeah.
This section, sorry, I'm taking so much of this talk, but this section really made me nervous, right? Because I feel like, I mean, I think that a long time ago, I remember going over one of some paper on synthetic data and sort of like methods where like self-improvement kind of hits a limit pretty fast. So it's interesting. They really like sort of emphasize the self-improvement aspect here, and it just seems like you might like squeeze the most out of the existing data set, but you're gonna maybe be overfit or something. I don't know.
Yeah, I mean I was worried about that because like they use a lot of synthetic data, but I think even though it's like synthetic data, the reward function probably captured like enough reasoning capabilities, so generalize well. Uh, that's what I was hoping for.
Yeah, yeah, I mean,
Sorry, could I ask a question about what is meant by self-distillation? Maybe I didn't quite catch what they're actually doing here.
Mm, I I think they were using like expert model to generate the response, and then they were using non-expert model to use that expert model generated reasoning. I think they call it self-distillation, but it doesn't make sense.
It feels like reading from this, it feels like what they're saying is that they use an IO like trained model and feed that response into an SFT. But that's kind of like weird to do that, right? So I don't quite understand why somebody would do that.
Wait, no, so
Uh,
this is common. They did this in Magistral. Basically, when you run out of like a good verifier and like training data, they trained a very good math model. So basically in Magistral Medium, they retrained a reasoning model just on math, and then they use that model to generate math data. So in this case, they do the same thing, right? So stage one, you train experts, right? Like reasoning agent, tool use agent, general chat agent, then you do this unified training with distillation. So right, so the agents generate responses and reasoning and tool calls, and you know that's then the unified model is trained on this synthetic data. It's like self-distillation because it kind of came from itself, right? They branched off, trained experts, and then they train on that output. So distillation per se.
Oh, so Before you're saying that they were the trained on specific tasks, and then use because they were specific. Then for the unified one, you kind of like use that specific RL trained one to kind of like generalize to other tasks, or at least you kind of put all the I guess you call it experts, right, on different tasks. Try to use the combined into another SFT run.
Yeah. So they use the experts to generate response reasoning tool call traces, right?
Yeah. Okay.
That's the distillation. So they basically get they train experts to do output rollouts, and then they train on those.
Okay.
This is like how Magistral got reasoning. They trained a good math model, then they used it for data. It's like a very clear example of like this idea of training another model to generate some of this data. Would recommend that paper or a paper club on it. But yeah, makes sense.
mm, this is like a general comment. It seems like uh, increasing the interaction terms with the environment has obviously improved the test time compute. Um, I think this is like a generic statement. It doesn't have any value. I mean, it has value, but it doesn't like any specific insight. And for general oral, they use like oral HF and then oral AAF. They use like a model-based feedback as well. Depends on the data, depends on the task. Like the kind of mixing or use mixing all these three approaches, like a rule-based feedback. I think depends on the task. Like one of these would be better. But I feel like even models can give like a better judgment for a lot of tasks. Yeah. What is this chart? Yeah, this is like a browser comp accuracy.
Browser comp, very interesting benchmark. This is from OpenAI. It's like their web search type thing that they released with deep research. I think they updated it recently. I think Six has played with it a bit. The interesting chart I found were like the two in section 3 actually. There's two charts about training, about multi-step, and um what do these red and blue lines? Um Yeah, they're multi-step training. They have these two charts that kind of break down multi-stage versus single stage training and breaking off of difficulty problems and plateauing. These two are pretty cool.
Right.
Honestly, I think since we're running short of time, maybe we don't just look at chart, but they had good charts. I recommend charts.
That's true. Um,
And on that last point, by the way, with the distillation, so like the high level process is like first you train the three experts, right? Reasoner, agent, and general chat. Then, you you train them with a cold start of SFT traces, then you do RL, you make them experts. Then the big thing is like you don't just train on their rollouts like flat out, right? They do a lot of filtration. So like for the distillation from three experts, they do rejection sampling, correctness checking, reward model filtering, tool call verification. Like they actually verify all this stuff. Then the unified model, they do that SFT distillation sort of stuff, and that's like a deep level of like filtration stuff. I think that's one of the interesting things, right? It's not like they just do three models and then they merge them into one, like some weird model merge or some ensemble. It's just that they use them for synthetic data and then they distill down. And it's like a bunch of just SFT kickstart, do RL, okay, generate data, filter data. Let's do it again. Let's do SFT as a kickstart off of these. And of course, strip out some stuff like you want hybrid reasoning, so you want to keep some reasoners, keep some non-reasoning stuff. And in the end, you get one model that outperforms the three.
Is it normal?
Also,
Oh, sorry, thank you.
go ahead, Brad.
I just ask one more quick question. It says here, like, once training has reached certain step count or plateaued, is it normal that they loop the distillation process?
That they what the distillation process?
Like they're doing many rounds of the self-distillation.
Once training has reached a certain step count or plateaued, we apply self-distillation by substituting the original cold start data with responses generated by the RL, thus creating a superior SFT. We then conduct further RL training to enhance this model. This is talking about training the experts, right? Then conduct further RL on this. No, this is the join. Increasing difficulty. This strategy allows us to push the limits of RL train models of it. Sorry, what's the question here? This seems somewhat standard approach. But I think I misinterpreted what your question was about this.
No, it's okay. I might be misunderstanding. I just got the impression that something that they're doing differently is it's a self-iteration loop rather than just running the distillation process once, which is what I thought the other models were doing.
Apply self-distillation by substituting that. I think the loop is just like, after you do easy questions, you do hard questions. Like that's their whole multi-step thing, right? Like they at different stages do harder and harder questions and they're mixing it in with context length. They show this in one of the like I think is it figure 5 about moderate and extreme difficulty, whereas one plateaus, they switch to stage 2 with extreme difficulty and then progress continues. So like that blue line, if you keep it stagnant with the same difficulty, that's where it starts to plateau and you're not improving accuracy. So, next cycle is just extreme difficulty instead. I think that's what they're saying here. It's just tiers of harder and harder questions. I could also be misinterpreting this,
That seems to be my understanding as well. They mentioned like how they created like a reward function for each type of specific task. They were checking format, they were checking like trajectory, and then they were also checking if sometimes like so this stepwise it's basically checking like did we call exact tool at the particular time, and sometimes they're using that, and also they're trying to see if you actually completed the task other than like just calling the function at particular time. So they were using these two. And then sometimes these RLs, they get into infinite loops. So and then instead of adding a penalty to the task, like they sampled a lot of prompts where the RL tends to get infinite loops, and then they created like a penalty function based on that instead of using a standard penalty, which is like sample inefficient. They mentioned like how they mentioned how they want to use like a GPU better ways. If some RL it's taking a lot of time to finish, like instead of waiting on that, they created like a different platform to optimize like a GPU usage better. You can read the details later. And then yeah, these evolution metrics, how they compare against existing models. I don't like this. Seems like a very straightforward to me. It's not like a I think it's cool. Yeah, but it's still a lot of times it's still second to Claude or other. Maybe the model sizes is like very small compared to them, but still, um, nothing new inside. It's just like a metrics they're talking how it compares to other models. I feel like one interesting thing they were able to have like a. I think the model has like a lot of reasoning capabilities inbuilt. So it gets like a emergent phenomena, like the translation surprisingly works comparatively existing models. So that's like a side effect of having a lot of reasoning tokens. Yeah, I think that's all I wanted to cover. But I feel like the oral setup, the things they have mentioned is very cool.
Well, thank you so much for presenting. If anyone wants, next week volunteer. There's always fun papers. I posted a bunch in Discord, or if there's any topics you want to cover, we can cover together, But big shout out. Thank you so much for presenting. It's always fun to get different perspective on this stuff,
Thank you, Vibhu.
Yeah, it
Um,
was well done. Thanks for volunteering. All right, we need more
Thank
volunteers.
you.
More papers. Somebody's gonna do C dance. That's another one.
Oh shit.
China models, man.
China models
I
are,
really want to do a China tour at some point. Maybe early next year. Go
oh
China.
my God. You just have access to go see all the labs. Here they're very hush
I
hush.
can definitely get Quen. We have inroads to
Wow.
DeepSeek.
Ooh,
And then step 5 mini max for sure I can get.
my God.
So Zhipu, which is GLM. I mean, I don't think they're hard to get, but I don't currently have context.
Okay, other papers though. There's Meta's Dino V3. There's a Genie clone that came out of Tencent. What else? What else? There's a survey on parallel text generation. There is a lot of stuff. There's a few autoregressive image generation papers.
Ooh,
Okay,
HRM. Tyler's volunteering HRM. Yes, I
okay.
haven't read that one and I need to read it. So HRM is yes on the docket.
In the next 2 to 3 weeks, I might reach
We
out
need to do HRM.
to Jay Alamar for
Ooh.
his GPT OSS thing. I'll share it in Discord. If you guys haven't seen it, he did a really good blog post called like the Illustrated Transformer, Illustrated BERT GPT-2. He put out one yesterday, I think, on the Illustrated GPT OSS. So it's like a good visual breakdown of what's happening in state-of-the-art MOE models. And I'll share it in Discord and try to get him to come up on. Otherwise, if you have paper, it's always better. Someone else volunteer.
Okay, Tyler, you're locked for September 5th. September 3rd, GLM. Sorry, HRM. And then we need a
Tyler.
volunteer for next week.
Cool. Thanks,
All right.
guys.
Bye all.
Bye.